In this video, we're going to go over the Lab 9 Wingate data analysis. So, I have everything I need. I have my Wingate data that's pulled up here in Google Sheets, and on the left here I have our worksheet. So, I have my data from when I did it. I actually did this, so those of you who did it, I suffered along with you, so to speak, or had the pleasure of doing it. We have a couple tabs here that we have at the bottom, or sheets. The only one that we'll actually need is this bicycle one. We don't really need the other ones, but some of the results they don't make a lot of sense from what it's automatically doing, so we're going to automatically try to calculate some of this stuff, or calculate it in a quick way. So, starting here, we have a bunch of data. This is in seconds for time. One thing before we get started, we're going to go ahead and do view and freeze and just first row. That just keeps our header always at the top. So no matter how much we scroll down, it's always up there. We always know what we're going to be looking for. So I zoomed in a little bit. You may have a better view. Sometimes my larger screen doesn't look so good on smaller screens, such as your laptop and whatnot in a video. So I wanted to make that a little bit larger. Let's go ahead and add some columns to the right here. And we're just going to make these few things over here. So let's go ahead and do peak power in watts. And then I'll just copy and paste that, edit, so I don't have to type the whole thing again. We'll just copy and paste those. We'll change this to average power. And this one, again, average power. Easy peasy. Power drop, percent. Then we have average metabolic power in liters per minute. And lastly, relative power. This one is unitless. Units will cancel out, so it's going to be unitless as we call it. All right, I'm just going to double click these, just expands it on out. Make sure I know which ones I'm going to be doing. Before we start punching in any calculations, I'm going to scroll down. Now you may have a little bit less data up front. So I did 5 minutes of warm-up, and then it did 30 seconds of the test, and then 5 minutes cooldown. Yours is probably going to be a little bit shorter, just for time's sake and all that. So I'm just going to scroll down. Oh, popped me over there. Scroll down until I hit about 5 minutes, which in this case would be, was that 300 seconds? Okay, going down, 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 down. Actually, we can speed this up a little bit. I'm just going to hold Control down, because I know where there's a cut in here, or where there's breaks already. So yeah, for me, it's 300 seconds. And here's where the test really starts in terms of counting. So, because I did 100 watts for warm-up, then it said, okay, here's where we're starting. And I'm just going to insert 2 rows above, so that I get all the data for the test here. And we can see that this B is load. That's the load that I'm pedaling against, or producing, 834 watts. Here's my RPM, my revolutions per minute. I didn't have a heart rate monitor on this time. How much distance has been covered in that time, the set accumulated energy, load in watts per kilogram. It's just load divided by my body weight. METs, metabolic equivalents, my pace. I think that's per mile, something per mile, minutes per mile, or something like that. And then braking torque, acceleration, and Wingate load. These are more what the Wingate itself is doing. We don't need to concern ourselves too much with that, other than everything on mine looks fine from what I know what this stuff is. So then I'm also going to come down to the end. So I'm going to start from the same place, go down, and it's 30 seconds, easy enough. Insert 2 more rows, and this one's going to be actually above. Cool, so that's my entire data, and same for yours. So Actually, I put them below this. That's okay. I'm going to move mine actually all the way down here. Just make it a little bit simpler. Alright, so peak power. Let's do max function. Come on over to load. Peak power in watts. And it's easy enough to tell on mine at least. Yours may be different, but mine's easy enough to tell. And then same thing here. Unfortunately, I just can't pull it over because these columns are not right next to each other. So, there we go. And yep, it should be at the exact same place. 10, mine somehow came out to a very even number of 10 versus, you know, all those digits. Just happened to work out like that because, as you can see, my body mass here at least was measured 83.4. All right, average power. So, average watts. So over that 30 seconds, averaged 588 for myself. What was my average watts per kilogram now? Great. All right, so power drop. This one is going to be peak power minus the minimum power that I had for this. So minimum, I'm going to actually have to calculate it, calculate it. Okay, so do that function first. Make sure you close all those parentheses. Then divide by, again, max power times 100. So we're taking the difference, how much that difference was, and dividing by max power, and then multiplying by 100. So how much did it drop over that period? And it was 47% for myself at least. All right, average metabolic power. This one's going to be a little bit more fun to do. So here we're going to calculate an average of something. We're going to do the METs column. METs, metabolic equivalents. Close that parenthesis. Before you hit enter or return, we have to do a few things. Metabolic equivalent, we need to convert this to milliliters per kg per minute. Now if you remember what that is, it's about, if we do rest, just what we assume rest is 3.5. So times 3.5 converts that from METs to milliliters per kilogram of body weight per minute. Now lastly, we need to convert from that to liters per minute. So to do that, we need to multiply by by body mass. In my case, 83.4, so make sure you punch in your mass or the person's mass. That's equivalent over here for the subject. And divide by 1,000. Okay. Should get something along the lines of such like this with one maybe two, depending on the person, digits in front of a decimal. But it's not going to be huge like 30 or 1,000 or something like that. All right, and now relative power, which is going to be this average metabolic power that was sustained over that period divided by VO2 max. Now, average metabolic power, we're not actually using O2 for that exercise, but we're looking at what would be the equivalent of using O2 for that. We're obviously using mostly anaerobic power. So now we'll take average metabolic power, divide it by that person's VO2 max, in my case 4.032, and this says my average metabolic power for this was 1.86 and change, times higher than my VO2 max. Okay, there's no way I can maintain that for any amount of time using oxygen because it's so much above my VO2 max. So yeah, that makes sense. I should be able to generate a lot more power via anaerobic processes than I can using oxygen. Now, if you just want to come back to our sheet here we have metabolic power and mechanical power. We should be able to generate a lot more using our ATP phosphocreatine and anaerobic glycolysis than we can aerobic processes. Does that make sense? All right. So then you can just go ahead and copy and paste this on over, and then you have to do it for the other 3 subjects. Same thing. All right, so one thing beforehand, if you are doing this before you do the force plate calculations, make sure you do not enter this mass that's here, or was it used for the Wingate, into here in the force plate calculations. Reason being, the force plate calculations, you'll actually calculate mass from what the force plate is measuring. It's very important we do that, because if you do it in a different way, then you can get some really wonky numbers. I've seen some numbers where people were off by about 50 newtons, which doesn't sound like much, but 50 newtons, and it looked like they were jumping 10 feet into the air. And it's like, okay, well, obviously they were not jumping 10 feet into the air. So it does matter. We need what was actually measured by the force plate. The scale, so to speak, always matters. What the scale is reading and which scale is doing the measuring. So we need to make sure those mass numbers are separate. This is one specific to what the force plate is doing. All right, so if you have any questions, that's about it for this. But if you do have any questions, just please contact your lab instructor or myself. You can also put these numbers down here for the Wingate and also force plate, just from here and here. And on the force plate, it's a separate place that you'll copy and paste them into here. Otherwise, have a good rest of your day, and I will see you in the next video.